Hi folks, in this lesson today what we're going to be learning about is what is a flat file database. We're going to be learning the need for a relational database. We're going to be learning about normalization, the stages of normalization, and how normalization can aid us to create an ER diagram. We're also then going to learn how a link table works in an ER diagram and why we need to have it for our A-level coursework. So let us begin. What is a flat file database? Simply, a flat file database is all the data recorded in a single, simple table. So all the data is recorded in a single, simple table like this here. This would be used for very simple lists like a list of Christmas cards or a list of your own CDs and so on and so forth. But there is problems associated with it. If we look at this order form here, each time we want to record the details in a single form, for all these things that there are multiple of, we're going to have to put them onto a new row. So every time we'd have to write in the date, the order number, the account number, the customer name, the customer address for every item that they've ordered. And you see there's all their details there, and these are the things that are called like repeated fields. They're causing the rest of the details to be repeated, so I've highlighted them here in yellow, and they are the repeated fields. The problems associated with a flat file database are this. Because we have to enter the data many times, there can be errors whenever we're entering this data many times. These repeated fields are causing us to repeat all this data, and because of that, errors and inconsistencies can occur. Whenever we're defining this, we're going to have to look at certain words. We're going to have to look at the words consistency, we're going to have to look at the words redundancy, we're going to have to look at the words integrity, and so on and so forth. So let's look at the problems with a flat file database. If I go to this example here, hopefully you might see it a wee bit better. I've entered these details in many times, but if you look at the spelling of the word Corey, you'll see that it's different in two different places. This is what's known as an inconsistency, and it causes data consistency problems. It means that if you want to send out a letter to this person because the address is wrong here or here, you don't know which one's the right one. There's also problems with this thing called duplication and redundancy. We have to enter these details in many times. This is what's known as data redundancy. That data is not needed, it's redundant. It should only be entered once, and this data duplication can cause the consistency problems that we're seeing here. So if you look at the Corey here and the Corey here, you'll see that there's consistency problems. There's also data integrity problems. We don't know how accurate or true this data is. So these are the main problems associated with a flat file database. So how do we solve them? We solve them by moving away from a flat file database to a relational database. Things that are repeated twice, we take them and put them into separate entities or tables. These separate entities or tables allow us to only record the data once, so there's less duplication of data. It also means there's better data consistency and there's better data integrity. So let's look at the next thing here, the purpose of normalization. This is a textbook answer that you would need. Now this question, they could ask it in many different ways. They could say, what is the advantages of a relational database compared to a flat file database? And the advantages are simple. It's the most efficient and best design possible. There's also unnecessary duplication of data in a relational database. There's little redundancy. Again, look at that word redundancy. Therefore, there's less chance of inconsistencies and the data is more accurate. Its integrity is greater. So this is the reason that we're doing normalization. This is the purpose of data modeling. This is the purpose of of normalization. This is the purpose of creating a relational database. So let's look at the stages. The stages of normalization are this. The first thing that we're going to have to do is write out the attributes correctly. This is a skill in itself, because what you're going to need to do is you're going to need to highlight the repeating fields. You also might want to write them out in shorthand code, because you're going to have to write them out a lot. This writing out the attributes was what would happen if it was a flat file database. So 0NF is like a flat file database. Then what we're doing is we're improving the flat file database to make it a relational database. And we're going to have to do this thing called first normal form, second normal form, and then third normal form. So let's look at it. Let's look at the skills firstly about what we're going to have to do whenever we're doing this. The skills that we're going to need to do is this. Before we attempt normalization, we're going to have to write out all the fields or attributes using shorthand code. we're going to have to highlight any repeating attributes by placing brackets around them. If I go back to the very top slide here, you'll see that I've highlighted them here. These are the things that are causing the rest of the data to be repeated. These are the repeating fields or groups of attributes or fields that we're looking to repeat. I've also highlighted them here. And we'll go back to it. We're going to have to highlight them by using brackets. We're also going to have to underline any key fields. Now, a key field is something that makes that record unique. So it would be like an ID number or something like that. So we're going to have to go into each one of these entities or objects or tables, and we're going to have to highlight any key fields. Remember, all entities should have a name and should have a key field. So if we look back to that problem we were looking at a second ago, we get something like this. Okay. So if I was writing these out, what would I write out? Well, I can see here we've got a date, and I can see these here are all for an order. So I'm just going to write out the fields first, just to make it easy. So we've got date, then we've got order number, then we've got the account number, then we've got the customer number, customer address. Then we've got these repeated fields, so I'm going to put them in brackets. We've got the item code, we've got the description, we've got the quantity, we got the unit cost, that's my brackets end. Then what we've got is we've got the order total. So there is them all there in shorthand. The other thing that we have to do is we have to firstly name my object, and I could say that these are all for the order forms, so I'm going to call them orders. I'm just going to highlight that. That's the name of my entity there. So there is the name of my entity. And I have to highlight the key field. So this is for the order form, so I'm guessing that the thing that makes it unique is the order number. And I'm just going to underline that. I'm also going to highlight these here because these repeated fields are the things that we're going to have to move in a second or two. So in a second or two we're going to have to move, let's see if I can put it in a better colour, we're going to have to move them repeated fields. And that's it there. That's the flat file unnormalized database would look like. So we've got the date, the order number, the account number, the customer name, customer address. These repeated fields, we've highlighted them in red, I've highlighted them in yellow here, and we've got the order total. The order total does not go in here, it's not been repeated many times. It's just there. So there's it there. So that's our zero normal form created for us. We have highlighted any repeated attributes by placing brackets, we've underlined the key fields, and we've named our entity. That's the skill in itself. Then what we do is we move on to first normal form. So we're going to need to know the definition of first normal form. Now the definition of first normal form is this. A table is in first normal form if it contains no repeating attributes or groups of attributes. So them fields that are causing the rest to be repeated are what's known as repeating attributes or groups of attributes in simple terms. You need to memorize that stuff in red. That's the stuff that you're going to need to know. So how do you do it? To conform to the first normal form rule, it's this. You take the entities that are repeated, you make them into a new separate entity or table. But so that you don't lose any information, you must place the key of the original entity into the new entity, making a composite key. Now you're probably wondering, why do we take the key and put it into this new one? Well, these tables have to be related. And every time we do first normal form, you will create this thing known as a composite key. It's very important that you understand that. Every time after doing first normal form, what you should see in any exam questions is a composite key. So let's look at it. If we look at this example, this is our zero normal form here, and we're going to have to now convert it into first normal form. So we need to take the repeating attributes, which are these ones highlighted in red, and we need to put them into a new separate table. So I'm going to take these out. I'm going to go down here, I'm going to paste them in, and I'm going to have a separate table. I also need to take the key field here and place it in here. So I've got order number, and the name of my entity is very simple. These here are all the order items, and the key field that's needed to identify these order items are these both together. These two fields together would identify the order items ordered. The clue is actually in the name. So this is the name of my entity. Okay, so this is the name of my entity. So these are the order items, and these here is going to be contained in the order table, and to link them two together, that order number is going to be used to link them two tables together. So after doing first normal form, what we should get is we should get two tables. We're going to have an order table and an order items table. They're going to be linked together using the order number, and this is the composite key here that we talked about. It's very important that you understand that a composite key, these two things are needed to uniquely identify the order items. The clue is actually in the name, order and items. The order numbers needed and the item codes needed. So let's move on now and see what second normal form is. So this is just the first stage, splitting it up into two tables, an order table and an order items table. You need to do that first before you progress to second normal form. So what is the definition of second normal form? Second normal form is this. A table is in second normal form if it is in first normal form and contains no partial dependencies. Now you're probably wondering what this word partial dependencies mean. Well, in first normal form we created a composite key. We have to examine that composite key and see, is there anything that only depends on part of that composite key. If there is, we have to take them out and put them into a separate table. The reason for that is this. If there is something that depends on only part of it, we're repeating it time and time and time again. There's redundancy there, and what we want to do is we want to reduce that redundancy to make it more consistent and to make it a better model. So how do we do that? Well, we examine the attributes or the fields in the entity with a composite key. Any with a partial key dependence should be removed and placed into a separate entity with a link. If we look at this data here, this is what we've got in first normal form here. So we've got these here, and we've got this thing highlighted in red here. This is our composite key. What we need to do is we need to look at the data, and we need to see, does anything only depend on part of it? So let's start with this here, description. We don't have to worry about this table because there's no composite key, but this table here has a composite key, so we need to examine it in detail. Now, does the description depend on the item, or does it depend on the order and the item? So does this description here, does it depend on just the item, or does it depend on the order and the item? Well, I know that the description only depends on part of it. It only depends on the item code. So that's what's known as a partial dependency. That description will always stay the same regardless of the order for that item. However, if I look at the next field, the quantity, this is the quantity that was ordered of that item, if that makes sense. So the order number and the item code are both needed. That's a full dependency. I'm going to put I'll put an F there just to show that it's a full dependency. They're both required. That their quantity depends on the item and the order number. It's not always going to stay the same for the item number. So it's what's known as a full dependency. If we look at the next one, the unit cost. The unit cost is always going to stay the same for that item. Therefore, it's what's known as a partial dependency. It's not going to depend on the order and the item, it's only going to depend on the item code. So if we look at this here, just write we small p's or f's beside it, and we change this here. Now I know that these things here are going to have to be taken out and put into a new item. And that item is going to be the items table, and it's going to consist of the description, and it's going to consist of the unit cost. And I take these out of here, and there's my order table, there's my order items table, and this is my items table. Now I know that these only depend on part of it, and the only thing that they depend on is the item code. And there's my link between the tables, and there is my key field. So how are these tables linked? The order table is linked to the order items table through the order number. That's the link. The items table is linked to the order items table through the item code, and there's the link there. And then we've got second normal form. We've removed any partial dependencies. So we can see how our system's getting a bit better. Lastly, what we need to look at is we need to look at third normal form. Again, you can't skip ahead and do third normal form. You have to do first normal form and second normal form. So what is the definition of what is third normal form? Well, third normal form is this. It must be in second normal form and contain no non-key dependencies. What does that mean? Well, every attribute must depend on the key, the whole key, and nothing but the key. If you see anything that depends on anything else, that there could cause data duplication. It could cause inconsistencies. Therefore, we need to take it out and put it into a separate entity or table. So how do we do this? We do this by placing the attributes with the non-key dependents into a new entity with the attributes they depend on as the key. If we look at this example here, okay, this is my second normal form here. But if I look at the data in more detail, if I look at this data here, is there anything that depends on something else? And I could see that the account number, the customer name and the customer address, well, these here details here depend on only the account number. I shouldn't have to write in the account number, the customer name and the customer address every time this account number purchases something. So what I would have to do is I'd have to take them out. Okay, so I would take out these fields here. I'm just going to highlight them. I would take out them fields there and I'd place them into a separate table. So what I'm going to be left with is something like this. So I'm going to take out these fields here. I'm just going to copy them and put them into a separate table. These here are the customer's details. So what I'm going to have is I'm going to have something that looks like that. The key field is going to be the account number. And I take out these fields. But what I do is I leave in this field here. This here is what's known as a foreign key. This is used to link these two tables together. So to link this table to this table, this here is what's known as a foreign key. It is a field inside this table that is a key field in another table. That is a foreign key. That's what's used to link them two tables together, so that a customer can place many orders and stuff like that. And there, folks, we have our third normal form. We're going to have four entities. We're going to have the order entity, the order items entity, the items entity and the customer entity, and there should be no repeating of data. Whenever we record a new customer, we just record them on account number, name and address. Whenever we're doing a new item, we put in the description and the unit cost. Whenever we're doing an order, we put in the date, we put in the account number and we put in the order total. We'd also put in the order items, which are all linked together. So third normal form, we can see that there's four entities. I've got them in the next table. Here they are here. The next thing that we'd have to do is we might have to do an ER diagram. Now I know that there are four entities, so I put them in little boxes like this. What an ER diagram is what's known as an entity relationship diagram. In most examples, I would recommend that you get to this stage here, the third normal form, before attempting to draw an ER diagram. In most questions that they ask you to make sure that there's not a many-to-many relationship. So you need to look at these here and draw an ER diagram. Well, what's the relationship between customer and order? Well, I know that a customer can place many orders, but each order must only have one customer number. I couldn't have two account numbers in here. It wouldn't make sense. So a customer can place many orders. This moves us on to the next stage. There is a problem here, and we've kind of solved it. The problem is one order can contain many items, and an item can contain many orders. So what we need to do is we need to create a link table between these here. So to remove this here, we need to create a link table between these here. What does the link table look like? Well, I can tell you that every time you do this, the link table will look something like this. We've got this order items table that's going to consist of the order number, the item code and the quantity. And what we're simply going to say is that each order can have many of these order items, but the items that are ordered can only be contained once on the order items table. That is our finished ER diagram, and that solves the problem of a many-to-many relationship. There's only a one-to-many, one-to-many, many-to-one relationship here. That is our ER diagram. This solves the problem of this many-to-many relationship. Thanks for listening.